Hey guys, we're going to work on verifying equations. So the next 3 slides I would write down on a piece of paper and save that piece of paper because you can use this piece of paper on your test. So this is my check to see that you're watching this video. Write these next 3 slides on a piece of paper. So the first thing is a refresher on reciprocals. So sine x is the same as 1 over cosecant x, which means that cosecant is 1 over sine. Cosine of x is the same as 1 over secant of x, which means that secant is 1 over cosine. And then tangent of x is the same as 1 over cotangent of x, which means that cotangent of x is the same as 1 over tangent of x. So pause the video, write that on your piece of paper. The next thing is our quotient Ids, which just means that tangent of x is the same as if I put sine of x divided by cosine of x, which means that cotangent is the same as cosine of x over sine of x. And then our last one is our Pythagorean Ids. So sine squared of x plus cosine squared of x will always equal 1 no matter what the degree is. And then 1 plus tangent squared of x is the same as secant squared of x. And then 1 plus cotangent squared of x is equal to secant squared of x. So using these Ids, our reciprocals and everything, if they give us sine, we can find any of the others. Cosine, we can find any of the others, and so on and so forth, by replacing, removing, and manipulating these equations. But these 3 equations will get us all of the answers we ever need. So what it means to verify an equation is they give us an equation, they give us the answer. All we have to do is prove if it's true or false. At the end of the day, it's a 50-50 guess if you're right or wrong. So how we do this is we're going to make every single thing equal to sine and cosine. So my secant squared, I'm going to change to 1 over sine x, and tangent is going to be sine x over cosine x, and then secant is 1 over cosine x. This way we're using common terms. Instead of 3 different terms, we're just using down to 2. So now I'm going to multiply 1 times sine, and then sine times cosine. I have a sine on top, sine on the bottom. Those cancel. I'm left with 1 over cosine of x is equal to 1 of cosine of x. So that's equal to each other, so we say true. So again, the first thing I'm going to do is convert everything into being sine or cosine. Then multiply. So now I have sine squared of x over cosine of x plus cosine is equal to 1 over cosine. So I need to make this a fraction so I can combine with this one, and I want to have the denominator of cosine. So cosine over cosine is just 1, right? So that doesn't change the value of the equation. So I'm going to multiply this by cosine over cosine. So then I get sine squared over cosine, which is cosine squared over cosine, which is 1 over cosine. Now I can combine this into a single fraction. And then our identity says sine squared over cosine squared is 1. So that gives me 1 over cosine of x, which is what I had on the other side. So these equal each other, so that is true. Again, my first step is to make everything be cosine or sine. So this first one is good, the second one is good, and then let's worry about this at a later date. So let's just finish the left-hand side. So to make these have common denominators, I need to cross multiply. So this one would be 1 minus cosine times 1 over cosine. This one would be 1 plus cosine over 1 plus cosine. So now I get 1 minus cosine plus 1 plus cosine. And it's all over 1 plus cosine theta times 1 minus cosine theta. So the next thing I'm going to do is I'm going to combine like terms and FOIL. So 1 plus 1 is 2. Negative cosine plus cosine cancels. And then down here, FOILing, I get 1. And then I get plus cosine minus cosine, so those cancel. Minus cosine squared. So then, my next step is 1 minus cosine squared. Well, that is cosine squared and sine squared equal 1. So if I subtracted cosine to the other side, that would be the same as sine squared theta. So that just reduces this one gets. So let's see if it equals what I want it to equal. So let's factor out the 2 first. And I have 1 plus cotangent squared of theta. And then let's make this equal to sine or cosine. So because it's cotangent, it's going to be cosine over sine. And because it's squared, these are going to be squared. Then I want to make this 1 into a fraction so I can combine it. So then I would have sine squared over sine squared now that I have common denominators, I can combine the tops. So I would have 2 sine theta on one side, and then 2 sine squared plus cosine squared of theta over sine squared theta. My identity says sine squared plus cosine squared is the same as 1. So I have 1 over sine squared of theta. And 2 times 1 gets me to this. So those are the same. So that is good. Our last one, we're going to make everything equal to sine or cosine. So cotangent is cosine on top, sine on bottom. Whereas tangent is the opposite. So sine on top, cosine on the bottom, and we'll worry about what it equals in a little bit. So I want this 1 to have a matching fraction. So it's going to be sine over sine minus cosine over sine. Same thing over here, matching fraction. This denominator is cosine. Then I'm going to combine my fractions. So I have sine x over sine x minus cosine x all over sine. Whereas over here I have cosine x over sine x minus cosine x all over cosine. So I have a fraction over a fraction, which means flip the fraction and then multiply. So then I would have sine times sine over sine x minus cosine x. Same thing on this side. So now I have common denominators. I can combine these fractions. So then I would have sine squared x minus cosine squared x all over sine x minus cosine x. If this was plus, it would just be 1 and we were done. But because it's minus, we have to factor. So it's going to be sine plus cosine of x and sine minus cosine of x. So if I were to FOIL, I would get sine squared, cosine squared, and the b term would cancel. And this is all over sine x plus cosine x. I have pairs, so I can cross those out, and my final answer is sine minus cosine of x. And if you would remember at the very top of this problem, it needed to equal sine x plus cosine of x. Okay, so because it's, minus, so these should have canceled, so they should have been plus. So those match, we did a good job.